So there's just going to be kind of some different scenarios, some different information thrown your way. So let's get started. Parallel slopes. If lines are parallel, we know that their slopes are equivalent. What does equivalent mean? It means equal. So, or same slope. Either way you want to think about that. But if lines are parallel, they're going to have equivalent slopes. Perpendicular slopes are, think in switch and flip. So we say opposite. And to flip a fraction, that means, or that's called reciprocal. So perpendicular slopes are opposite reciprocal, meaning you switch and flip it. So if you start off with a slope of 3/4, you would change it over to -4/3. Or if you're starting off with the slope -2, it would change to +1/2. So notice the signs changed and the fraction flipped. Graph the following equations and determine if the lines are parallel, perpendicular, or neither. So these are set up nicely. They're all in y equals format, so that's nice. So let's just start with that very first line. So if I'm graphing this line, I'm going to start with my y-intercept, which is -4. So I'll go down to -4, put a point. And then my slope is 2/3. So I know that's my rise over my run. So I'm rising 2, and I'm going to go to the right, 1, 2, 3. And I will put a point. You can do it a couple times, 1, 2, 3, if you need to make sure you have enough points to graph it. And then just use whatever straight edge you have. Like I've said many of times, I am not perfect at drawing lines or even close, as you can see, but try my best. Okay, the next line is going to have a y-intercept of +1. And again, the slope is 2/3. So that's something we're looking at. If they have the same slope, what are we already thinking? So up 1, 2 over 1, 2, 3, put a point. 1, 2, 1, 2, 3, put a point. And draw my line. I noticed that those lines look like they will never cross, and I know in my equation my slope is the same, so those are going to be parallel lines. Moving on to the next one. Starting off with this first line at +7. So 1, 2, 3, 4, 5, 6, 7. And my slope is -5, which means I would be going down 5 and to the right 1, because even though it's not a fraction, you know that whole numbers are put over 1. So the rise is -5, so dropping 5, and the run is 1. So again, 1, 2, 3, 4, 5 over 1. Connect those points. So that slope's -5. When I look at my second line, positive, so opposite, 1/5. So that would be that opposite reciprocal, the switch and flip. So I'm thinking perpendicular when I look at those slopes. I'm thinking perpendicular. When I put it on the graph, I'm at -8. Going up 1. And over 1, 2, 3, 4, 5. And I notice when I draw out these lines, and I always in the beginning forget, but remember to put my arrows on the end because they are continuous lines. But what I notice is that these are going to cross. And something you want to think about with perpendicular lines is that they create a right angle. But we know for sure it's perpendicular because if we look at the slope, -5, switch and flip, opposite reciprocal, 1/5. So that's how we got that to be for sure perpendicular. We didn't just eyeball it on the graph. We actually took a look at it in the equation. Example 3, y equals 4. X equals -7. So what this is saying is that no matter what your no matter what your X value is, your Y value is +4. So that's going to be a horizontal line. And X equals -7. No matter what your Y value is, your X value is -7. So that's creating a vertical line situation. We are going to get to that next, but horizontal and vertical lines are always perpendicular. So this would be a perpendicular situation. Now this last one, I'm not going to graph it out, but I do just want to talk about it. If you notice, this slope is 1/3. This one is -1/3. So even though it changes signs, it's going to be neither because it's not the same slope. And it's also not the opposite reciprocal. It's just the opposite. So this would be neither because they aren't the same slope and it's not opposite reciprocal. Okay, going to that next page. If you're looking at the equations and you're identifying it as parallel, you're thinking same slope, perpendicular, opposite, reciprocal. So that switch and flip we talked about, or neither. So if you look here, -4, -4, those are going to be the same slope, so that would be parallel. We talked about on our last example that if you have a vertical line and a horizontal line, those are going to be perpendicular. Camera. There we go. And example 6. We have 4 and we have -1/4, so those are opposite reciprocals. So those would be perpendicular lines. And finally, this one is not set up as y equals mx plus b, so we are going to have to solve for y. So on this first one, I would subtract 4x and get -3y equals -4x plus 2. Divide both sides by -3. And remember, you have to go all the way through dividing by -3. Y equals a negative and a negative become positive. So 4/3 x minus 2/3. Can leave it like that. And then I will go ahead on the other one, solve for y. So this time I'm going to be moving my x. So plus 3x. That's going to give me 4y equals 3x plus 20. And then I'm going to divide everything by 4. That will give me y equals positive 3/4 x plus 5. So notice 4/3 and 3/4, those are flipped, but they're both positive. So this one would be a neither situation. Okay, last section of these notes is talking about parallel, perpendicular, but dealing with horizontal and vertical. So we kind of already mentioned that. Horizontal lines will always be y equals some number. Vertical lines will always be x equal some number. And like we said before, they are always perpendicular. So horizontal and vertical lines are always perpendicular. Write the equation of a line that is parallel to the x-axis. So we know the x-axis is the horizontal axis. So we're going to need a horizontal line. So we're thinking y equals something, but it has to pass through the point 4, 3. So if we know this is our point, and we know that's an x and a y point, and our line has to be horizontal, and it has to go through that point, I know that my equation would have to be y equals, because that's the y value that we were given. So y equals 3 would be parallel to the x-axis, and it would go through that 4, 3 point. Write the equation of a line that is perpendicular to the x-axis. So we're thinking vertical. So we're thinking x equals whatever. And it goes through the point -2, 5. So if the x is -2 and it has to go through that, our equation for that line that is vertical, which in turn is perpendicular to the x-axis, would be x equals -2. So it's super important to read carefully, make sure that you're thinking parallel, perpendicular, and then also make sure, like on this one, it switches over to the y-axis. So write an equation of a line that is parallel to the y-axis. If it's parallel to the y-axis, again, we're thinking vertical, and it has to pass through 310, so therefore I know it would be x equals 3. Last one, perpendicular to the y-axis, so that's going to be a horizontal line, and it passes through the point -3, -9. I know my horizontal lines have to be y equals. If it has to pass through this point, I know this line would have to be y equals -9.